Hey, what's up, Ziguanas? This is day 9 of the 30 days of Zig coding challenge. Join me one more time as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language. And for me, that language is Zig. My name is Dusan. Welcome to Zignited. So yesterday I finished, not finished, but I've done pointers in Zig for the 3rd day in a row. So I will stop there for now with pointers, and today I will focus on slices. So let's start with slices. Let's see what they say here about slices. And again, for the ones of you who are watching this for the first time, basically I'm documenting my process of learning a new language. I didn't have any Zig experience back like 10 days ago. So I'm documenting my process of learning a new language, and I try to apply everything that I learned so far in my previously mentioned experience, and I show how I demonstrate how I would approach learning a new language. So this is day 9. So far I've been reading a lot of official documentations from documentation from the Zig lang.org, and I mentioned in the first video that it's more important to practice things than to actually just like watch tutorials and read docs. So that's why I try to experiment. I don't just like copy paste the code from the docs. I try to play with it. I try to hack it, try to break it, and so on to learn, let's say, the details. Of course, I cannot go deep at the beginning because I don't know the language. So I'm trying to cover as much as possible topics, and then let's say in a few days, I do plan to actually pause with reading the documentation, and I will try to create something like a mini project or something that I will also be doing live. But for now, I'm going through the documentation and trying to cover as much as possible of the basic things. That being said, let's jump to slices. Let's see what they say. A slice is a pointer and a length. Okay. So they combine the pointers plus the length. Basically the offset. I mean, the maximum offset would be the length, right? And the difference between an array and a slice is that the array's length is part of the type and known at compile time, whereas the slice length is known in runtime. Aha, okay. This is interesting. So yeah, it makes sense. So a tiny difference, like, I mean, tiny under quotes, which actually they used to make two different types. Okay. Both can be accessed with the length field. Yeah, but in this case it works in the runtime only. I mean, it's known in the runtime, and in case of arrays, it's known before during the compile time. Let's see the examples. Okay, these are the imports, and let's copy these few things and then paste here. And I will change it a little bit. So yeah, this is an array of i32s, so integer with size 32. Then we have 4 elements inside, 4 integers. Then we have another variable known in runtime 0, use size equals 0. Okay. Then they have the underscore known at runtime 0. Okay. Then they create a slice and they say it's going to be an array. Then they take this variable that is known at runtime. So they start with this one, and this one is 0. And they go up to the array length, which in this case should be 4. So basically it's literally like saying from 0 to 4, and it's not inclusive. The endpoint is not included, so it basically means all the first 4 elements, which are in this case all of the elements, because it's about indices, not about the ordinary numbers like in most of the programming languages is the same. Okay, so let's try to print now. And let me see. Here, this is a variable, an array. Then this is a variable. So let's see if it's going to complain, because if I don't change variables, usually it complains. The compiler contains. Let me see if this is going to be the case here as well. And let's do what I want to print. I want to print the slice, just to see how it looks like. Yeah, I want to print the slice. The slice here. And let's run the code. Unused argument, yeah, slice. So in slice. Okay, yeah, because I was about to say I'm using it here, but yeah, it's in slice. Let's see. Unused argument slice. My mistake. Sorry, I keep forgetting that I have to interpolate here. It's not going to just print on its own. And I believe I have to say any here, just to. Okay, nice. Just to see something, because they say here at the beginning, not here, here. They say slice is pointer and the length. So because it's a pointer, I'm just curious to see if I put a star here, which I know can be used to interpolate pointers into a string. I just want to test if this is going to work with slices as well. Maybe I did this already before, because when I was reading about pointers, they mentioned slices. Yeah, obviously it works. Okay, nice. And I'm keeping opening the wrong one. I will just leave this one. Okay, let's see the next thing. Alternative initialization using result location. Alt slice. Oh, this is interesting. So reference operator. I don't know how they officially call it, but this is a reference and then the dots notation. So I've never seen this. Let's see how this works. And I guess this doesn't complain because I don't. No, actually, I'm not sure, because usually if I create a variable, if I don't change it, if I don't mutate, it complains, but I keep mixing them up. I'm still new to this Zig way of thinking. So in this case, what we are doing with this one, we are just using it here and we are not mutating it in any way. Anyways, let's go back to this one here. So alt slice is the name of the constant. This is the type. And then we do this. Let's print it out. Oops. And this is now alt slice, not the slice. And I'm always forgetting these \n to go to the new line. Yeah, works nice. They have different memory addresses. So because this is a literal, they don't, of course, they will not have the same address. They're different arrays. So I do believe this is an array. It's because I'm confused because I've never seen this notation that they use reference dot notation to take this literal, which I believe is an array. So let's try debugging this, printing this out, and let's see what they are. So I will use the type of built-in function. And I want to do, let's start this first with this one. I just want to do step by step. So this is what exactly? Should be array, if I'm not mistaken. What does it say? Expected equal found, curly brace, copy paste problem. Okay. What does it say now? The same error. Where? 69. So the only closing one, they point to it, yeah, it's this one. So maybe I cannot just use, okay, again, copy paste problem. So this is nested into the call of type of, and that is nested in this one. Again, what am I missing this time? So let's just do this first, just to be sure. Type of, and then let's just do this, just to, or sanity check if I missed. I'm missing actually the parentheses of these. Okay, got it. So let's do this, and then so these are the curly braces of the array. This is the parentheses of, yeah, this is because I'm not using IDE, I'm using this online thing, so it's harder to spot. IDE would usually help and highlight things. This is from here, and then I'm missing one more. Okay, hope I got it right this time. No, still something crazy going on. So let's focus. This one here should be closed here. Then I have these curly braces. Oh, it does help, so it does highlight here. Okay, then we have these, then we have these. So now, no, this one is highlighting it in the wrong way. So this is correct. These parentheses here are from here, and why it thinks this is, let's just do one thing. Again, sanity check. So instead of these, I'll just do number 1. Too few arguments. Where? Okay, because this is now a different thing. Because I had star. No, still. What I'm making some error that I cannot see now. So comma after the quotes, that's correct. I do have these curly braces for interpolation. I have a dot notation, and then type of here with parentheses. So let's do even one step further. One step more back, I wanted to say. What is happening here? Is it here? Was it here for the entire time? And I was debugging the wrong one. No, it's not about that. So let's try this. If I comment out this, again, sanity check just to see this works. Yeah, this works. So it's definitely here. So let me double check. Wait, am I crazy or what? So let's do this, and then let's just change this into And then here I will do something. Maybe the escape sequence. No, but I didn't use any weird characters. So let's try this. Okay, this works. Then let's try this. Okay, so here is where the problem starts. And let me try to do the full thing. So actually I can copy just this part here. Maybe simply the expression itself is not allowed in the formatter in this way. Actually I was using it in type-of. Yeah, so this works. So definitely something about this expression the compiler doesn't like. So I used it in my case inside of the type-of because I wanted to do step-by-step check of the types, but I couldn't. So it looks like I cannot use this one without something in front like this or this. So this is not accepted as a literal. Okay. So what if I did 1, 2, 3, and 4 like this? Just like separate the numbers with comma. Just curious, not related to arrays. Just like, yeah. Okay, so this is now there just like 3. Yeah, because commas, okay, because they are now the things that I want to pass 4 arguments to the formatter, and that I will have, so I should have then 4 pairs of curly braces here. Do that, but that's not what I want. I just wanted to test. Okay, now it makes sense. Let me just then see what's the type of this thing, because I cannot check the type of the core part of it, because it's not a valid expression on its own. It doesn't mean anything. Then type of, my mistake. Okay, so let's be precise here as well. Two arguments now. Why? So it's the same like this here. Let me double check. Yeah, it's highlighting it. So I just want to one more time do the following. Now again, just for the sanity check. And it's type, so I don't need these. Maybe that was ruining things. No, but let's see one more time, something like this. Come on. Why again? I'm going in circles. Wait, if I delete this part here. Oh, so I've... Let's just simplify. Let's say something like t equals, and let's make this very simple. So t equals curly braces backslash n, comma, dot, and 1 here. Okay, this works. Now let's go back to type of, and then let's do this. Again. Okay, comptime-int, and then one more time, try this. Okay, finally. So, what does it say? It says, wow, this is some type. Let's see what they say. Construct. So this is, this is a struct under the hood. So it is some struct literal, I guess, some anonymous struct literal. And it consists of these four things, which are all, in this case, comptime ints with these four different values. Okay, okay. Okay, so I haven't touched structs yet. I think they are after slices. So I'm not going to dig deeper into this for now. I just want to try one more time the simplified version of this. Just double check it doesn't work as. Yeah. Okay. So this doesn't work. But if we go back like this, it does work. Okay. And I think I had the same code here, and it didn't work when I had these kind of things there. So maybe some of these inside is messing things up for the formatter. I'm not sure. So I will have to double check that. But I will not do it now. I'm not going to do it now. Okay. So let's go to the next example. Okay, this is just testing. I don't want to use this expect equals. So I guess what this does is saying the type of the underlying elements of the slice, and then they are just comparing these two with this function here, but I'm not going to do that. Let's see what else they do. They're asking if the type is equal to this. And it's interesting that they're not trying to see what's the type of the other one, of the out slice. Because here the type was completely different. And I haven't printed the type of this one, so let me do that first. So let's say the type of this one. And let's try and see here what it is. And this is the type of out slice, the other one. Yeah, so this one is much simpler. Straightforward type. But this one is a pointer, a constant pointer to the struct. Okay. Okay. Let's see the next one. Slice 0 with index 0 equals the reference, not the slice 0. So the reference of slice square bracket 0 equals the array 0. So this should be the case because they use the slice where it was here from the beginning. It was here at 0, so from the first one. So this should be true. Let's print this instead of expecting. So it's here, and then let's interpolate. And I want \n as well. Okay, do I call them slice and array? Yes, array and slice. The same because I pasted. And semicolon here. Yeah, it's true. And then the length. Yeah, this is what I mentioned before, that you can actually have a length of the slice because it's not directly integrated into it, but it is kind of coupled with it somehow. Let's run. What did it say? Yeah, it's true. They have the same length. Okay. Then the next thing, if you slice with comptime-known start and end position, like in this case, right? This was known and this is runtime. Yeah, this is not comptime. Yeah, forgot. Let's see what they say. If you slice with comptime-known start and end positions, the result is a pointer to an array. Rather, okay, rather than a slice. Okay. Array. And then they ask if the type of the array pointer is equal to the pointer of array length of byte 32. Okay, so this is just to test if it's an array. But wait, here they said... okay. Yeah, I got it. So this is related with this thing where they said it before. Where they said it? Here. So the difference between an array and slice is that the array's length is a part of the type and the known at compile time. So this part here, actually I wanted to point to this part here, array length. So this is known at compile time, and this is literal, so no variable, nothing. So this is known at compile time, which basically means that both start and end positions are known at the compile time, which makes this slice actually a pointer to an array. Okay, let's test this, and I'm going to play it then to see if I just make some of these unknown at the compile time. So if one, did we have that example actually? So let's see here. The first slice was known in runtime 0 and array length. Yeah, so basically here it was that case where only this was known at the compile time, and this part here only during the runtime. And then it was not the case. Okay, so let's just try this one here. And I can comment out these things I have now. Okay, this is a constant. Array pointer equals array from 0 to the length of the array. And then I will change this into print. Okay, so print. And here what I want to do, I don't want to do this equal part. I'll just do the same thing like usual. So I want to put this thing here, and then I want this under quotes. Can I highlight and just press quotes here? Yes, I can. Perfect. So let's do this. Type of array pointer equals, and then this thing here. Okay. I'm trying to see if someone is writing on the chat because I've missed a few messages in previous streams. I use an found declared integer array where okay, this is something I have to keep. Yeah, so this is the pointer to the i32 array with size 4. right? So they were asking here. Yes, exactly that. Okay. And actually, let me see. The other pointer was this one, right? Yes, this one, slice. And I did print the type. I just wanted to compare one more time. So this one. Okay, so for this, I have to then uncomment this as well. So array known find time is here. Then this is just to use it so that it doesn't complain. Array length, okay. And then I just wanted to see the type of a slice. Do I have it here? No. Okay, I thought I printed it out, but it doesn't matter. I'll print it now. Yeah, so they are different. And let me just print with backslash n here. Yeah. So they aren't the same. This is the slice. This is an array. Okay. And they say a slice is a pointer and the length together. Okay. That's why we don't see any length here, because we have to do .len to see it. Okay. Then let's go to the next example. This was the last thing I did, right? Yeah. So let's see the next one. You can perform a slice by length by slicing twice. This allows the compiler to perform some optimizations, like recognizing a compile time known length when the start position is only known at runtime. Let's see what they will do. So let's copy paste all these things here. So they still depend on the array. So that's the one that I'm not going to comment out. So this array is the same one from here. Runtime start here. Okay, length they define here. And now let's see the code. Actually, let me think about what they are doing. So runtime start variable, use size integer with the value of 1. Then they use this to prevent from the error that I'm not changing this one. That I'm not. Yeah, this is actually kind of cool that this counts as changing. Okay. Const length equals 2, so one constant. Then another one here, array pointer length equals. Then they say it's an array, which is here starting from the runtime start, which is coming from this variable, so it's not known in compile time. This is the start point, and then they do this here from 0 to the length, which is again, no, length is a constant here. Okay, so this is basically known at the compile time. This part is not. And then let's see what they are getting here. I will print again. And this is what they expect. But I'm actually going to print and see if this is the case, if we are going to get that. Okay, so this one I want to put under quotes, and I also want to say this. Unused local constant slice where, okay, here. Let me comment out these again. I think this is what they were expecting. So pointer 2, in this case the size is 2, the length is 2 of I32. Let me just see one more time what they were explaining here. You can perform a slice by length by slicing twice. So they're slicing here and here. This allows the compiler to perform some optimizations, like recognize a comptime-known length when the start position is only known at runtime. So here, this is the start position known only at runtime, and they are optimizing at least for this part here. Okay, so they say in general they will know the length here in this case. Okay. So I will still have to play a lot with these to actually completely understand them. But for now it's okay. I kinda get the main point. But I would probably now at this level never remember to do this on my own if I want to do something. Okay, using the address of operator on a slice gives a single item pointer. Yeah, I was saying today at the beginning that kind of like I'm done with pointers for now. I'm going to play with slices, and then a slice is just a pointer with length. So yeah, basically day 4 of pointers. Using the address of pointer on a slice gives a single item pointer. So they take this address of operator. This is the official name for it. So it's I was calling it reference, but the official name is address of operator. Okay, so if I use address of operator on a slice, maybe they actually mean this operator is when you use this in the combination of with square brackets. I will have to see the official definition to understand if address of operator stands only, even if you use only this, or in the combination with square brackets. Okay, but anyways, here they say give me the slice with square bracket 0, so the first element of a slice, and then because of this operator they are actually getting that as an address, and because you're now asking what is the type of that address, it will say it's a pointer to the integer with 32 bits of length, because this is what's inside of the slice. Okay, let's see. I will take this here, and because I have only type of slice is the same. Wait, which slice they're referring to? The one that I commented out from the beginning, this one. Let's see if it appears somewhere else as a variable. No. Yeah, so they are speaking about this one here. So I will have to uncomment again these few lines of code to play with this part here. Okay, and I wanted also to print one more time the slice because I forgot what was inside. I think it was 1, 2, 3, 4, but just to confirm that, so I'll take this, and let's say here slice inside. Okay, and then for the second one, I actually want to do, and I remember to do the backslash thing, and I will need to do it here. Yeah, that's the last one. And then I want to do it here for this, because I want to see its pointer to I32. I believe it is, but I want to see. Okay, so this is expected here to be I32. And let's run. The slice cannot be formatted without S or any. Let's do, so it's here, right? So let's do any. I forgot about this. Okay. Let's see, yeah, the slice is 1, 2, 3, 4. So if we take here the slice square bracket 0, meaning first element, it's 1. And then the type of that will be the pointer of I32, because we are asking here for the address. Okay. Nice. And it's cool name for the operator, address-of operator. Okay, let's see the next two. And first, let's read what they want to say. Using the PTR field gives a many item pointer. So this one here, what we had yesterday, something similar. Or maybe the day before. This is not here. Just double check. It's pointer, not PTR. Okay. Back to this example. So many similar things. Again, it will take some practice to memorize all these. Okay, let's copy this here. And then let's print them. So this is expected to be many item pointer. And we will see what it will be. And the second one, it's basically the same. Just its type of, instead of type of is this one. So I'll copy paste this part, it's easier. And replace with this built-in method function instead of type of. And this is the expected type, right? So let's do this. So actually not a type, but the integer from pointer. Oh, backslash n, I forgot. And I have an error. So let's see what's an error. What's the error? But I also want to fix these backslash n things. Expected semicolon after statement where I don't see that I'm missing, so I have it here. Here, which line? 26. Maybe again copy paste problem. Let me just try to delete this part. This is from the type of. This is from. It looks like. Okay, why it says I'm missing. just to see if this works. Wait. Again, let's minimize. T equals dot. Oh, come on. Okay. Here, I'm missing a dot. Yeah, sometimes it's kind of like misleading you. So it was missing here the dot, not. Oh, is it possible that this is what I was missing at the beginning? And I spent like 20 minutes of running in circles. Okay, now it's a different thing. 2667. So again, something here is off. Again, let's simplify. Let's do this. I see. Okay. I see what I did, but I want to do this. Maybe it's the previous line. Let's try like this. If I comment out this part. Yeah, I think it's the previous line because now it's switched to the next line here. So let me test here what I did. So if I just say T here, and then here I can also simplify this to 1. Wait, I just want to be completely sure. Now it works. So let me then undo the changes here. I think this line actually worked, line 25 before. So it has to be then in 26, 27. Yeah, so let's try this one. Yeah, this one works now. And this is the correct thing that we were expecting. So let's try the next one. Okay, let's now try to simplify this one. Say T equals, and then here as well. Let's inject just number 1. Dot. Come on. Where is it here? How come I noticed one dot missing, but I didn't notice this one? Okay, so far this so far the hardest part of Zig for me is the dot notation. Like so many times I didn't see it. Okay, so let's see here. We get. I even forgot what I was trying to do. Let's go back here using the pointer field, like here. We get a many item pointer. Okay. So type of slice PTR is this one, many item pointer. So that's correct. And then when that is used to convert to an integer, it gives this. And this is a memory address, right? So this is a memory address, I believe. But just converts to an integer. Okay. Okay, let's actually test that. I just want to do one more thing. So this part. But this time I'm not going to do the int from. I'm going to say this. I want to see the slice pointer itself. Let's see what is there directly. What did it say? Ah, pointer. Server. And I want to, let's change this into hexadecimal, that's easier. So here, when I convert it to an integer, let's do hexadecimal version of it. Yeah, they are the same. So it's an address. And when I was doing, so is there another one? So dot pointer, but it was mem dot pointer, so it's a different thing. It was not from the, okay, I will just like rewatch the video that I made yesterday so that I don't waste time on the things that I went through already. I would prefer finishing this slicing part. So this is what's left, and let's see what is then. This is for strings. Oh my god, there is a lot of them. I mean, it's cool. Just I don't want this stream to go forever. So this is, we are almost at 1 hour from the beginning. So let's finish just this part, and then tomorrow I will do this other part of slices. Yeah, because there is a lot more about slices. Okay, so let's try to do these 5 lines of code that are left today. Slices have array bounds check-in. Okay, if you try to access something out of bounds, this is what I tried to hack yesterday, I believe, you'll get a safety check failure. Let's try to do that. Panic. Index out of bounds. Index 10. Okay. The PTR part does not invoke the safety checking, while and slice 0 asserts that slice has length of greater than 0. Okay. So this part here does not invoke safety checking. Okay. As long as slice 0 asserts, no, it's not as long. This is like while slice 0 asserts that the slice has length greater than 0. Okay. A lot of these things are very confusing how they explain, so I don't understand the context for what they're saying. I mean, this is like the case with any documentation. It's not a tutorial, it's a documentation. That's why you try things on your own. Okay, so this part is panicking. Let's comment that out. And let's say this will panic. And let's move on to the next example. Empty slices can be created like this. Let's do the empty one. I forgot to comment to copy the entire thing. And let's print that empty one. And yeah, it has backslash n. That's what I wanted to see. So I don't believe I need this star. It can be any or star because it's slice. So let's leave star, doesn't matter. Just want to see. Yeah. Oh, nice address. So length 0, U8 at this memory address. Okay, the next one. If the type is known, you can use this shorthand. How come this is a shorthand? This doesn't look... I mean, yeah, this is basically they're speaking about this. So yeah, this part is short, but I was just like looking at the entire expression. It's not that big of a difference. Okay, but yes, the right hand value is shorter. So let's try doing this. And before I run it, I just want to see here a zero length initialization can always be used to create an empty slice, even if the slice is mutable. Okay, this is because the pointed to data is 0 bits long, so its immutability is irrelevant. So the data that it points to is 0 bits long, so it doesn't matter if it's immutable or not. Okay, got it. But I'm just thinking when this has the actual implementation value. Maybe I'm missing something. Okay. Let's do another one here. I want to print the empty tool just to make sure they're the same. And then finally, I want to print these guys. So I can do 2 of these. And then I can just copy paste here and here the first part, and then the second one. Yeah, this one and this one. What happened? Non-pointer type. Now because it's an empty one. Oh, wait. Where is it in? Wait. I just want to see where the problem is. This is the first part that was changed. So this one is fine. They're different. So what were they saying here? The first one is empty slices can be created like this. Type is known. You can use the shorthand. Zero length. Okay, so now they're speaking about this because it's zero length. Can always be used to create an empty slice. But they are kind of both empty, but it looks like they're empty in a different way, as far as I can tell. Maybe I'm wrong, but this is how I see it, because here also they appear in a different way. So they are kind of both empty, if I understood correctly, but here you explicitly say there are zero elements, and here you just have the pointer to an empty. And I want to see what is the type of this first of all. Let's see, just to understand better. Is it again the struct that is empty? So it looks like they use these struct literals to make slices and arrays. So not these, but I want to see the type of this thing. So oops, type of this thing here, right? Yeah. And let's do that here as well. Okay, will this run? Dot curly braces, because looks like interpolation. So let's say like this, type of, and then I will know what it is here. Just I will just maybe check if this runs, how this works, because I'm curious, but I just first want to see this part here. What is the type? Okay, now I get the same error like before. Cannot format non-pointer type. with, so what it says basically, if I understand correctly, is that it doesn't see the empty slice as a pointer at all, because by the definition they said slices are pointer plus the length, but because this is an empty one, for some reason now it's not the same type. And only in this case, like when we have it like this, in this case, because there is a size, but it's 0, that is explicitly said, then it's a different story. So let's try to do any here, probably it will work. Just to see. Yeah, but this is very interesting if this is what I think what it is, what I just said. So they don't even think about it as a slice. Wait, what does it say here? So it's a constant pointer to a type. Oh, this is very weird. Type of. So a type of this is this. The constant pointer to the type of. I'm confused. And if I say 1, 2, 3 here, then this will be the pointer to a slice or a struct, right? That was what we had before. Yeah. Oh, so weird. So if there is something in curly braces, it's a struct. And because of the address-of operator with a dot, maybe it's completely different when you use it. It's not that operator anymore. They have a different role for it. Maybe, I don't know. And if I do this, then suddenly it's not a struct, but the type of this thing here is basically this is a constant pointer to the type of dot empty curly braces. This is so weird. And this is so weird. So it's interesting, but it's weird. So anyway, now I know why this part doesn't work. So first of all, this is star. Shouldn't be there. Yeah, so the length of the first and the second is 0. And why, when I said star here, I got this weird error. I mean, I understand that the length is a number, it's not a pointer. I just want to see the error one more time. Cannot format with star operator on pointer. Okay, yeah, so this makes sense in this case. But by accident, because I had this bug, I mean, not bug, it was my error. So I got it, I copy pasted and I left the star, which basically is used only for pointers to format them. But this got me on this train of thoughts that actually made me play with this other thing. So the literal value that they use here, and they then say this is a slice of U8s, but the type of it is very weird. Okay. Slices are very interesting in Zig. Thank you guys for watching this. So tomorrow I think I will continue with this other part of slices that is left, because they are, I think they are important, so I want to wrap them. And I want to finish them, and then probably after finishing slices, I will see that I at least maybe go through functions, so at least through the basics of, because I guess if all these things so far are a bit more complicated because it's a lower level language, I guess the functions are also going to be interesting and more complicated than in some other languages. So for this reason, maybe I will just try to scratch the surface of functions after I finish with slices next time, and then I will do a small project, and I really mean small, so probably something like tic-tac-toe game that I will create in Zig to start with, just like practicing things that I learned so far. But I don't want to do that without functions because I don't want to repeat. Maybe actually I can. So I will see. Maybe I will even do it after I finish slices. Yeah, we can do that. I can finish slices the next time, and then I can do something like with loops without functions. I can make tic-tac-toe. Okay. Thanks, everyone, for watching today, and see you tomorrow. Bye-bye.